One customer gets charged and never gets a receipt. The next customer gets a receipt and is never charged. And nothing has crashed. No error. Nothing in the logs. Both services running perfectly. So, half your orders are broken and your system is telling you everything is fine. And the cause is one line of setup. Somebody pointed a second service at a queue that already had one. And a queue at high level is just a list of jobs waiting to be picked up. The thing is, a queue does not hand your job to both services, it hands it to one of them. So, payments and email are not both reacting to each order. They are quietly splitting the orders between themselves, roughly half and half. And each customer only ever meets half of your system. Now, the natural reaction is that the queue itself is broken. It is not. That behavior is the entire reason a queue exists. Think about it properly. Let us say you have 10,000 emails to send. You put them on a queue and you start one worker. Too slow, right? You start five more. And now the same work finishes several times faster. And the important part is they are not all doing the same email. Once a worker has taken a job, the others cannot see it, and let me be precise about that because it matters later. That is the queue's routing intent, not a guarantee. One worker should get the job. It can still end up running twice if that worker crashes halfway. The job comes back and somebody else takes it. So that is the first shape. And I would hold on to this word. A queue divides work. Many workers, one list, each job going to exactly one pair of hands. That is not a side effect. It is the feature you are paying for. One precision here because interviews love it and most people mash it together. The queue promises that only one worker gets the job. It does not promise the job runs only one time. Those are two completely different promises. Because if a worker picks up a job and then dies halfway through, the queue does the right thing and gives the job to somebody else. And now part of that work has happened twice. So anything a worker does has to be safe to run twice. A second run must not charge the card again. One worker at a time, not once forever. So, our broken orders are not a broken queue. We asked it the wrong question, and that is genuinely the first of only two questions in this whole topic. Who needs to get this message? One worker out of a pool, sharing the load. That is what a queue is built for. Or every service independently, each getting its own copy, which is a completely different thing. We wanted the second one, and we built the first. So, the first thing you would probably try is give each service its own queue and have the order service put a copy on both. And honestly, that works until a third service shows up. And now the order code has to know about all three, and the fourth, and the fifth. Every time somebody new cares about orders, you go and edit the order service, which has nothing to do with any of them. So instead of the sender keeping a list of everybody, you just announce it. You publish the order to something called a topic, which is just a named channel orders, let us say. And anybody who has subscribed to the topic gets their own copy. Payments gets a copy, email gets a copy, and our bug is gone. This is called publish and subscribe or pub/sub. And the copying has a name as well, fan out. One message in, a copy out to each subscriber. So where a queue divides, pub/sub copies. And notice the difference is not about speed or scale or which product you bought. It is only about whether the message gets shared out or duplicated. And there is something more going on here as well. The order service no longer knows how many people are listening or their names. It says an order happened and stops caring. So when somebody adds an analytics service next month, they subscribe to the topic and the order service itself does not change at all. Somebody still configures a subscription, of course, but it is not a code change in the thing that does the publishing. And I think that is the real reason this pattern is everywhere, not the copying, the forgetting. Okay, so we ship this. It works. Everyone is happy. And then one afternoon, you deploy the email service. It restarts. It is down for, let us say, 30 seconds. And in those 30 seconds, four orders come in. Payments hear them, analytics hear them, and the email service, which is busy restarting, hears nothing. And when it comes back, there is nothing to catch up on. Those four customers just never get a receipt, and nothing anywhere reports an error. Now, plenty of brokers will hold messages for a subscriber that is temporarily offline. That is a real feature. It is called a durable subscription, and it is written into the specifications, not something one vendor added on top. And some go further. Google's PubSub can hold messages on the topic itself. So, a subscription created tomorrow can go back and replay things published today. So, I'm not going to tell you PubSub always forgets. That is not true. And you would rightly call it out. What is true is this: PubSub answers who gets a copy. It does not by itself tell you how long that copy is remembered. That is a completely separate decision. And once a PubSub product adds retention and replay, it starts behaving like the thing we are about to look at. So let us look at the second decision properly. What if being done with a message did not throw it away? So that is question 1 settled. Divide or copy. Now here is question 2, and it is completely independent of the first. What should done actually do? Up to now, done has meant gone. The worker acknowledges the job and the broker removes it. But that is a choice, not a law. So what if finishing with a message did not delete it? Instead of a list you take jobs off, picture a book. Every event is written on the next line and it stays there. Readers do not take pages out, they just read, and each reader keeps their own bookmark, their own position in the same book. The book does not change when you read it. And Kafka puts this better than I can in 6 words from their own documentation. Events are not deleted after consumption. Instead, you tell it how long to keep them, a time limit or a size limit, and it keeps them that long, whether anybody has read them or not. Not deleted after consumption. And that is the whole of the second decision right there. On a queue, saying done deletes the message. Here, saying done only moves your bookmark. The record itself does not move at all. So go back to our broken deploy. The email service goes down. Its bookmark just stops. The book keeps filing up. And when the service comes back, it picks up at a line 104 and works forward until it has caught up. Nothing was lost because nothing was thrown away. It was written down, and one reader was simply behind for a while. And that gives you something the other two genuinely cannot do. You can move a bookmark backwards. So, a service that did not exist last year can start at the beginning of whatever you have kept and read all of that history. Or you find a bug in how you calculated something. You fix the code, move the bookmark back a week, and run it all again. So, a queue divides, pops up copies, and a log remembers. So, if a log can do what the others do, and also remember, why is anybody still using a plain queue, right? First, because remembering is a decision you now have to make. The book cannot grow forever, so you choose how long to keep it. 7 days, let us say, or 30. And you choose that per topic. Too short, and the replay you are relying on is not there when you need it. Too long, and you are paying every month to store every event your company has ever produced. But the second one is the one I would actually worry about. With a queue, when things go wrong, you can see it. The workers stop and the list visibly piles up. It is right there in front of you. With the book, nothing looks wrong at all. The writers keep writing. The book looks exactly the same. Every reader reports that it is fine, and one of them is quietly falling further and further behind. Because records are not removed as they are handled, there is no backlog to notice. The only signal is the gap between a bookmark and the end of the book, and that gap has a name: consumer lag. You have to go and look at it. Nobody is going to come and tell you. So, the shape that keeps everything is also the shape that looks perfectly healthy while it is broken. And one more, replay means reprocessing. Those events go through your code a second time. So if the code charges a card, replaying it charges the card again, which is that same save to run twice idea from earlier, arriving from a completely different direction. So a plain queue is genuinely simpler to reason about. A log is not better, it is more. So, which one do you pick? And honestly, that framing is wrong because these were never three things to choose between. They are two dials. and real systems set both. Here is the shape you will actually meet, and AWS documents it directly. One topic at the front. The order is published once, and a copy lands in a queue belonging to each service that cares. Then, inside each service, 3 or 4 workers divide the queue between them. Copy between services, divide inside a service, and delete once the work is done. That is both dials set deliberately. And now look at Kafka because it settles the whole argument. Inside one consumer group, a record goes to one member, that is divide. Across different consumer groups, every group independently gets that same record, that is copy. And the record stays in the log the whole time regardless, that is remember. So Kafka is not one of the three shapes, it is doing all three verbs at once because they were never alternatives. Their own documentation says it plainly. The consumer group generalizes both of the old models. And this is where I owe you a correction. In the video where we built a queue, I said Kafka, RabbitMQ, and SQS were all just doing the simple thing. That was true enough to get started with. This is where it stops being true. Because people will tell you Kafka is a stream and RabbitMQ is a queue, and that is that. But a Kafka consumer group divides the work among its members, that is queue like behavior, in the thing everyone calls a stream. And RabbitMQ has had append only streams for years now. It goes the other way as well. The PubSub products added durable subscriptions and retentions precisely because a plain broadcast has no past. So, a product is not a shape. Some of them expose exactly one. SQS is a work queue, and that is all it is. SNS is a topic, that is all it is. Others expose several, which means the product name on its own does not tell you which behavior you are actually getting. You have to go and ask, does this message need to be divided, copied, or remembered? So, do not start with Kafka or RabbitMQ or SQS or any product name at all. Start with two questions. First, who needs a copy? If several workers are doing the same job, you want the work divided between them. That is a queue, and each job goes to one pair of hands. If several independent services all need to react to the same thing, you want it copied. One publish, one copy each, and the publisher stops caring who is listening. And second, what should done mean? If the message has served its purpose, acknowledge it and let it be deleted. Simple, cheap, easy to reason about. But if somebody might need to catch up later or replay history or a service that does not exist yet will need this, then you keep the record and only move a bookmark. And that one is not free. You are choosing a replay window. You are paying to store it and you have to watch the gap because a log looks perfectly healthy while a reader falls behind. And the two answers combine. That is the part people miss. Kafka copies across groups, divides inside a group, and remembers the record. A topic in front of queues copies between services, divide inside each one, and deletes when the work is done. So once you are asking these two questions, you stop arguing about which messaging product is better. You just ask what this particular message needs. See you in the next one.